with a unit circle. A unit circle is simply a circle with radius 1. Let's pick a point on this unit circle. We'll call this point x, y. That is, we move over to the right x units and up y units, leading to the point x, y. Well, if we look at this, what we've just done looks like a right triangle. Well, we've talked a lot about right triangles so far this course. Let's look at this right triangle and we'll call our angle theta. And if I look at theta and look at my x, my y, and my radius, which again in this case because we're dealing with a unit circle is equal to 1, the side opposite my angle theta is y. My side adjacent to theta is x, and the hypotenuse is r. Again, in this case, my hypotenuse is length 1 because we're using a unit circle. Once I have my sides in terms of opposite, adjacent, and hypotenuse, I should immediately think of my trig functions. Let's start off with sine of theta. Sine of theta, we've already discussed, is opposite over hypotenuse. Well, with this particular example, if I know the opposite side is y, and my hypotenuse is 1, then I can find that the sine of theta is equal to opposite over hypotenuse, or y over 1, or simply y. This also works with cosine. Cosine is adjacent over hypotenuse, and in this case, my adjacent side is length x, and again my hypotenuse is length 1, so the cosine of this angle theta is equal to x. Lastly, tangent of theta is equal to the opposite side over the adjacent side, or y over x. You'll notice that I've only talked about these three trig functions. We also have cosecant, secant, and cotangent. However, because these are simply reciprocals of these three trig functions, my discussions from here on will generally deal with only sine, cosine, and tangent. Looking at this, we should be able to figure out that cosecant of theta would be 1 over y, and secant of theta would be 1 over x, and finally cotangent of theta would be x over y. Again, I'm not going to specifically say this each time, but since you know those are reciprocal functions, if I give you sine, cosine, and tangent, you should be able to come up with cosecant, secant, and cotangent. Alright, well, we've already dealt with acute angles like we just did in quadrant 1. What if I wanted to take what we learned about angles larger than 90 degrees and do the same thing? Well, if I want to build a right triangle like I did before, I can't use that angle phi that I've indicated. I'm going to use, again, this angle theta. I'm going to call this a reference angle. A reference angle is the acute angle formed by the terminal side of a angle and the x-axis. In this case, it's closest to the negative part of the x-axis. And our angle that we're going to deal with is this acute angle theta. If I again label this point, well, now I don't have x, y. Now I realize that my x value in this quadrant, in quadrant 2, is negative. So I'm actually going to be talking about negative x, but y is still positive in quadrant 2. So my new point is negative x, y. My radius is still 1. My radius will always be a positive number. I don't have circles with negative radii, or I could think of this in terms of the Pythagorean theorem. The lengths of my legs squared is equal to that length of the hypotenuse squared. Again, when you square a number, even a negative number, you end up with a positive result, so my hypotenuse will always be positive. In this case, we know my radius is equal to 1. And I can still look at sine of theta as opposite of a hypotenuse, and the same with cosine and tangent. Well, for my sine of theta, if that's equal to opposite over hypotenuse, now that's still equal to y over 1, or y. But if I look at my cosine of theta, that's my adjacent side over the hypotenuse. But now my adjacent side is negative x. So it's negative x over positive 1, or negative x. My tangent is the opposite over adjacent, which is a positive y divided by a negative x, or this is equal to negative y over x. So it looks like in quadrant 2, my sine will always be positive because that y value is always positive in quadrant 2. But my cosine and my tangent functions, if the angle is in quadrant 2, will always be negative. Well, I didn't specifically look at this for quadrant 1, but if we remember, sine, cosine, and tangent were all positive numbers. So it looks like quadrant 1, all three of my functions are in fact positive. Well, let's look at quadrant 3. Again, if I move my angle phi into the third quadrant, that's where the angle would be between 180 degrees and 270 degrees, well, both x and y will be negative. So in quadrant 3, my point is negative x, comma negative y. And again, I can build a right triangle, this time my legs being negative x and negative y, still have that reference angle theta, that again is the acute angles formed by the terminal side and the x-axis, and my radius is still equal to 1. Again, sine, cosine, and tangent are as they've always been this semester, and hopefully always will be, but now my sine, which is opposite over hypotenuse, is negative y divided by 1, or negative y. Cosine of theta is adjacent over hypotenuse, or negative x divided by 1, or negative x. Tangent, however, is opposite over adjacent. That's equal to negative y divided by negative x. Well, we can reduce out a factor of negative 1, and that leaves us with y divided by x. So it looks like in the third quadrant, tangent is positive, but both cosine and sine are negative. Well, we'll continue going to quadrant 4. This time, again, we still have our reference angle that's between the terminal side and the x-axis, but now our x is positive and our y is negative. Our radius is still equal to 1, and now if we look at our sine, cosine, and tangent, we find that sine of theta in quadrant 4, that is when that angle is between 270 degrees and 360 degrees, is equal to negative y over 1, or negative y. Cosine is equal to the adjacent side over the hypotenuse, or positive x divided by 1, or positive x. Tangent theta is equal to opposite over adjacent, or negative y over x, or negative y over x. So in quadrant 4, cosine is the positive trig function, and sine and tangent are negative. If we take away everything and just simplify this, we see in quadrant 1, all trig functions are positive. Our sine, cosine, and tangent are all positive. In quadrant 2, just the sine is positive. In quadrant 3, only the tangent is positive, and in quadrant 4, the cosine is positive. Some students like to remember this by the letters A, S, T, C. Some people use the mnemonic. All students take calculus. So that is, all trig functions are positive in quadrant 1. This also includes cosecant, secant, and cotangent. In quadrant 2, sine is positive, as is cosecant, since cosecant is the reciprocal of sine. In quadrant 3, the tangent and cotangent are positive, and in quadrant 4, cosine and secant are positive.